In this lesson, we're going to convert equations between rectangular and polar form. You'll remember in lesson 1, we did this with points and converted an xy to an r theta and vice versa. Let's remember what those equations are. If I'm going from polar to rectangular form, if I want to calculate the x value, we can do it using the equation x is equal to r times the cosine of theta. And if we want to find the y value, we can use y equals r times the sine of theta. Now, if we want to convert from rectangular to polar, that is, we have the x and the y, and we want to convert to r and theta, we can find r by using r squared is equal to x squared plus y squared. That's just the Pythagorean theorem. And we can find theta by using the equation tangent of theta is equal to y over x. So bear those equations in mind as we convert each of the following equations. In example 1a, we have the equation x squared plus y squared is equal to 16. And we can make a direct substitution here of x squared plus y squared and replace it with r squared. R squared is equal to 16. Now we're going to want to solve for r whenever possible. And if it's not possible, then we'll solve for theta. In this one, we can solve for r. Now, you'll remember if r squared equals 16 has two solutions, plus or minus 4. But we're going to choose the positive one, r equals 4. r equals negative 4 would not be wrong. You can choose either of those two solutions, and either one would be correct. So I'll write the second one down here. Now, if you think about what that looks like in the polar coordinate plane, all of the points in the polar coordinate plane that have an r of 4 lie on this circle 4 units outward from the pole. And so that r equals 4 is the equation of a circle centered at the pole. And you'll remember that x squared plus y squared equals r squared is equal to the equation of a circle centered at the origin. So that one's converts nicely in both forms. All right, x equals 3, which is a vertical line. We'll convert that into polar form by replacing the x with r times the cosine of theta, and then solving for r by dividing by cosine of theta. And if we can write this in a form that is not a fraction, that would be most desirable. 1 over cosine theta is equal to secant theta, so this could be written as r equals 3 times the secant of theta. And there we have the equation of a vertical line in polar form. All right, let's check out the next one. Y equals negative 1 over the square root of 3 times x. Now there's a couple different ways that we can get at this one. If you can imagine, we could take and replace the x with r times the cosine of theta and the y with r times the sine of theta. If we did that, the r's would divide out, and we'd be left with something that might be a little bit more difficult to handle. There is a harder way, which that is, and the easier way to do this type of an equation. Might be not useful to note that this is the equation of a line which has a y-intercept. A line with a y-intercept equal to 0. Goes through the origin. So the easier way to do this is simply to divide both sides of the equation by x, and that's going to leave us with y over x is equal to negative 1 over the square root of 3. The y over x can be replaced with tangent of theta. And now this is an equation for which we cannot solve for r, and so we're going to solve for theta instead. So we need to find the angle that has a tangent equal to negative 1 over the square root of 3. So let's take a look at that. That's either going to be in quadrants 2 or 4, and so we can draw a triangle like this. And that would be a 30, 60, 90 triangle. The angle in question is 150 degrees. because the reference angle is 30. So we can write theta is equal to 150 as the equation of that line. So whenever you have a theta equal to a constant value, that means that all the points lie along a radial line, which is a line that goes through the pole. That's one solution that you can write. Now there is a second answer that you could give. You don't need to give both, but you can give either one of these. Theta equals 330 is also an acceptable answer. Right? Those are in opposite quadrants, so either one of those is fine. All right, in D, we've got an equation of a line in standard form. If we solve this for y, we'd have y equals mx plus b. We're going to leave it in standard form because standard form is going to be the easiest to convert into polar form. So let's take our x and replace it with r times the cosine of theta, and the y and replace it with r times the sine of theta. And now here's a nice algebra trick that you learned in Algebra 2. Before I do that, I need to make a correction. That second coefficient should have been a 3, not a 2. When you have terms that have, both terms have r in them, one of the ways that you can solve is to factor out that r. So r times 2 cosine theta plus 3 times the sine of theta is equal to 6, and then simply divide. R is equal to 6 over 2 times the cosine of theta plus 3 times the sine of theta. Now don't be tempted to reduce this one. We can't reduce if we have a binomial in the denominator, not unless we can factor a common factor from both the numerator and the denominator. So that's the equation of a line in polar form. All right, now let's take an equation in E that is in a little bit different form. This is actually the equation of a circle, and a circle has a general equation in rectangular form of x minus h squared plus y minus k squared equals r squared. So this is a circle that has a center at the point 3, 0 and a radius equal to 3. You'll remember that from Algebra 2. In order to convert this, the best way to do this is to simply go ahead and do that squaring on the x minus 3. So x minus 3 squared, remember to get your middle term from the inners and the outers. That's x minus 3 times x minus 3 is x squared minus 6x plus 9 plus y squared is equal to 9. Now you'll notice something, that I can subtract off those 9's from both sides, and we'll have a 0 left on the right-hand side. And then, from there, we can group that x squared and the y squared together, so that we have x squared plus y squared. And let's go ahead and add 6x to both sides, or move the 6x to the other side. It'll become positive. X squared plus y squared can be replaced with r squared, and x can be replaced with r times the cosine of theta. Now you might be tempted to take a square root to try to solve for r here, but that's not going to yield a valid answer because we'll still have an r on the other side of the equation, and you want r equals and then only thetas on the other side of the equation. So the easiest way, little trick here, to solve this one for r is to simply divide both sides by r. Once we do that, we'll have r is equal to 6 times the cosine of theta. So that's actually the equation of a circle centered at 3, 0 with a radius of 3. That 6 is actually giving us the diameter of the circle. All right, in F, we have another equation of a line. It's in y equals mx plus b form, but you'll remember from a previous example that it's easiest to convert the equation if the equation's in standard form. So first, I'm going to clear the fractions. 3y is equal to x plus 6. And then I'm going to shift some terms around. I'll subtract the 3y so that it's over on the right with the x, and subtract the 6 so that it's on the left by itself. And then the x is r cosine theta, and the y is r sine theta. Now factor out the r, and we have cosine theta minus 3 times the sine of theta. And r is equal to negative 6 over the cosine of theta minus 3 times the sine of theta. And there's the equation of our line. All right, a couple for you to try. Try this one first, y equals 4, and pause the video as you do this. Okay, here's the equation of that horizontal line in polar form, r equals 4 cosecant theta. Now try the next one, which is a little bit more challenging. This one is the equation of a circle centered at 0, negative 5 with a radius of 5. Pause the video as you do this one. All right, here's the equation of that circle in polar form, r equals negative 10 times the sine of theta. All right, now we're going to go in the other direction. We'll take a polar equation and we'll convert it back to rectangular form. Now, if you remember how we did the last ones, all we're going to be doing is reversing the exact same steps. So if we start with r equals negative 4 cosecant theta and we want to convert that back to x's and or y's, we are going to need to probably change the way this equation looks first. Cosecant theta is not one of those functions, trig functions, that is in any of our conversion equations. So let's convert this to r equals negative 4 over the sine of theta. Now let's multiply both sides by sine of theta. And now we have r times the sine of theta is equal to 4, and r times the sine of theta is y. So this must be the equation of a horizontal line, y equals negative 4. All right, let's check out b. R is equal to negative 5. You might already guess from this one that it's the equation of a circle. All the points that have the same radius are the same distance from the pole. And so the easiest way to convert this one algebraically is to square both sides. R squared is equal to 25, and then replace that r squared with x squared plus y squared. And now you have the equation of a circle centered at 0, 0 with a radius of 5. All right, let's check out C. R equals 4 times the sine of theta. Now we might be tempted to use r times the sine of theta is equal to y, but we don't actually have r times the sine of theta. If we moved that sine of theta to the left side of the equation, we'd have to divide it out. All right, so this one's going to be a little trickier. This one is actually the equation of a circle, and if you remember the process for the equation of a circle, the last thing that we did to solve for r was to divide by r. So in this instance, we are going to multiply by r. Multiplying by r on the left side, we get r squared, and by r on the right, we get 4 times r times the sine of theta. The r squared can be replaced with x squared plus y squared, and the r times the sine of theta can be replaced with y. Now, this doesn't look like the equation of a circle, so we need to move it into a standard form for the equation of a circle. And that's going to involve something that you learned how to do in Algebra 2, and I'm sure you loved, completing the square. So what we're going to do here is we're going to move the 4y to the left side to be with the y squared, and we're going to put a plus blank. On the right side we had 0. We'll also put a plus blank there because what we want to do is to balance the two sides of the equation by adding the same thing to both sides. And so what we're going to concentrate on right now is this y squared minus 4y plus blank. What we want to do with this is to turn it into a perfect square trinomial. Now if you remember multiplying in a box, we're going to essentially factor in a box, which is the same process in reverse. So we'll put the product on the inside of the box, y squared, and that middle term comes from inners and outers. We're going to divide it equally. So negative 4y can be divided up into negative 2y and negative 2y. And now we have the plus blank. The plus blank is actually this last square here, or this last rectangle. And so what we're going to try to do now is we're going to get those factors that go on the outside of the box, which are essentially the length and the width. Y squared is a product resulting from y times y. Now the other boxes have negative 2y as their area, so the y must have gotten multiplied by negative 2. So we have y minus 2 times y minus 2, and completing the square, negative 2 times negative 2 is positive 4. So we're going to put a positive 4 in the blank and add it to the right side of the equation as well. Y squared minus 4y plus 4 is, looking at that picture of the box, y minus 2 squared, or y minus 2 times y minus 2. And now we have the equation in the standard form for the equation of a circle, which is a circle that is centered at the point 0, 2, with a radius of 2, which is the square root of 4. That's our toughest one to convert. All right, in D we have r equals 6 over the cosine of theta minus 2 times the sine of theta. You might remember this one as looking like the same result that we got when we solved for the equation of a line in polar form. What we're going to do here is we're going to multiply both sides by the denominator first. So we have r times the cosine of theta minus 2 times the sine of theta equals 6. Distribute that r to the addition on the inside of the parentheses, and then convert x minus 2y is equal to 6. R times cosine of theta is x, r times the sine of theta is y. That's an equation in standard form for the equation of a line, so that's fine. If you want to, however, another acceptable form for the equation of a line is y equals mx plus b. So if you wanted to do that, that would be y is equal to 1/2 x minus 3 if you solve for y. I don't know why you would. You can just leave it in standard form. All right, let's check out another example. Theta is equal to 3 pi over 4. That one is a typo. Let's change that one in your copy. That somehow radians sneaked in here. That should be theta is equal to 135 degrees. All right. The best way that we can approach this one, since we don't have anything to convert at the moment, is to take the tangent of both sides. You might remember that tangent is kind of equivalent to rise over run or slope. So this is actually going to give us the slope of our line. Tangent of theta can be replaced with y over x, and we can find the tangent of 135 by making a quick drawing. 135 is an angle that terminates in quadrant 2, 45-degree reference angle. Opposite and adjacent are 1 and negative 1. And so that tangent would be 1 over negative 1 or negative 1. And now we can just solve for x. Y equals negative x. That is an equation of a line in y equals mx plus b form. If you like, you can also convert this one to standard form, which would be x plus y is equal to 0. Either of these two are acceptable forms for an equation of a line. Just has to be in some sort of recognizable form. All right, in F we have r equals 2 times the secant of theta. Let's take that secant of theta and make it a 1 over cosine of theta. Multiply both sides by cosine of theta, and then replace r times the cosine of theta with 2. And we get a vertical line, x equals 2. All right, here are a couple for you to try. Let's try this first one. Again, radians snuck in here, so let's change that pi over 3 to 60 degrees. Okay, go and pause the video while you do this. All right, for this one, you may remember when you have theta equals, the easiest way to convert is to take the tangent of both sides. Tangent of theta is y over x, and tangent of 60 can be, the value can be found, it's the square root of 3. And that gives you two possible ways to write this, y equals mx plus b form, or if you like, standard form. All right, one more for you to try. R equals 6 times the cosine of theta. Pause the video while you do this. All right, this one was a circle. Remember the trick here, take that both sides of the equation, multiply by r, that'll give you x squared plus y squared on the left side and 6x on the right side. Then you have to complete the square, so we get a circle with a center at 3, 0 and a radius of 3. What you'll notice about all of these circles that we write equations for in polar form is that they'll all have a radius equal to the distance away from the origin. So if it's 3 units away from the origin, it'll have a radius of 3. So it'll be tangent to the y-axis and or the x-axis. So interesting thing about those. We'll only look at that one type, really. All right, in the last few examples here, we're going to take and write our equations in rectangular form from a graph, and then we're going to convert into polar form. Now, of course, this one's just a line, so it should be easy to write the equation. Y is equal to mx plus b. So if we take a look at a couple of points that we can find here, looks like we have a slope of -2/3 and a y-intercept of 3. It's easiest to convert into the equation of a line if it's in standard form. So let's clear those fractions, multiplying by 3, and then move the x and the y terms to the same side of the equation. Replace the x with r cosine theta, and replace the y with r times the sine of theta. Factor out that r, and divide. And we get our equation in polar form. All right, let's move on to a circle that you'll notice that it's centered at the origin here. I'm sorry, it's not centered at the origin, but it's tangent at the origin. So what do we know about our circle? Well, our equation of a circle is generally x minus h squared plus y minus k squared is equal to r squared. And the center point is -3, 0. Well, if we subtract -3, that's like adding it. So we have x plus 3 squared plus, and y minus 0 squared is just y squared, equals r squared. Easiest way to convert this is to go ahead and do that squaring. X squared plus 6x plus 9 plus y squared is equal to, and you know what I forgot to do? I forgot to replace the r squared on the right side of the equation. Let's take a look at what our r is. Our radius is 3, so r squared will be 9. That 9 will be able to be subtracted off from both sides of the equation, leaving us a 0 on the right side. And let's move our x squared plus y squared together and subtract off 6x from both sides. X squared plus y squared is r squared, and x is r times the cosine of theta. Lastly, to solve for r, divide both sides by r. We get r is equal to -6 times the cosine of theta is the equation of this circle. In C, we have another line, but this is a very special line. It is a horizontal line, and all the points on this line have the exact same y-coordinate. All the y-coordinates are -5, and y can be replaced with r times the sine of theta. Dividing both sides by sine of theta, we'll have solved for r, but let's simplify this. That would be r equals -5 times the cosecant. Oops, let me make sure that I write that correctly. Cosecant of theta. All right, now I've got one for you to try. Pause the video while you do this. All right, this is one of our more involved conversions. You have to start with the general form of the equation of a circle. X minus h squared plus y minus k squared is equal to r squared. Replace the h with 0 and the k with negative. Oops, you know what? I misdid that one. I'm going to correct this one. K was 4, so that actually means that this should have been y minus 4. That's going to change that to minus, and that's going to change it to plus when we move it to the other side. So the equation should be r equals 8 times the sine of theta. And that's it for this lesson.